Many functions in calculus call upon domain restrictions. There can only be certain values that you can use, let's say when you take a derivative, when you do different things in calculus. And I've given you a list of common domain restrictions. Anything really outside those common domain restrictions, the domain would be negative infinity to positive infinity. If we look at E is a rational function, and because it's a rational function, we cannot divide a number by 0. So whatever is in our denominator, we'll go ahead and set that so it does not equal 0. And in this case, x cannot be 4. If we were to put that in interval notation, we would get negative infinity to 4 and then 4 to infinity. In calculus, most commonly, they use set builder notation. So you don't have to worry too much about interval notation, only when it applies specifically. Example F is a problem where we have a 4th degree function. There's nothing special about a 4th degree function in terms of domain restrictions. And because there's nothing really special about it, this quartic or 4th degree function has a domain of negative infinity to positive infinity. That would be the capitalized letter R means all real numbers. This is an example in calculus where you'd probably want to put things in interval notation just because it's an easier way to write it. So I think the best answer in this case would be negative infinity to positive infinity. Example J is a square root function. It is an nth root function that the nth root is even. So it does have a domain restriction. And the domain restriction, again, you cannot take the square root, 4th root, 5th root, sorry, not 5th root, 6th root, 8th root, anything that's even. You cannot take an even nth root of a negative number. Our radicand is the value that's inside the radical, and our radicand is x plus 4. And we'll go ahead and say take x plus 4 and set it greater than or equal to 0. And so our inequality is x is greater than or equal to negative 4. That would be the inequality notation, also called set builder notation, and interval notation is from negative 4 to infinity. Any numbers that are outside that interval, we would be taking the square root of negative numbers, which would get us imaginary and would not fall on the real number system. Example H is a cosecant function. A cosecant function has some domain restrictions. You cannot take the cosecant of 0 because the cosecant of 0 is undefined. You cannot take the cosecant of pi, as that would also get you something that would be undefined. If we look at the actual domain they give us, it's from 0 to 2 pi. So the two values that will not work for cosecant will be 0 and pi. And if we go ahead and take 0 and pi and make x subtract pi be so they do not equal those, we end up getting domain restrictions of x does not equal pi and x does not equal 2 pi. Keep in mind x does not equal 2 pi, but 2 pi is not actually on our interval. It's an open interval for 2 pi. So when we actually write it in interval notation, it will only be values from 0 to pi that work, and then from pi to 2 pi will work. If we look at I is a natural log function. Natural log function is a logarithmic function, so it has the same properties as any type of logarithmic function. Keep in mind that you can't take the log or natural log of 0, and you cannot take the log or natural log of negative numbers, so the only values that would apply would be values that are greater than 0. In this case, we've got a value of 2x plus 1, and 2x plus 1 we're going to go ahead and take and set greater than 0. When we solve that inequality, we get x is greater than negative 1/2. Our domain can be written as interval notation as well. Again, I would go back and probably leave our answer as the inequality x is, again, greater than negative 1/2. Example J is a tangent function, and because it's a tangent function, there's specific values that you cannot take the tangent of, because the tangent of pi over 2, for instance, is undefined. The tangent of negative pi over 2 is undefined, and so on and so forth around the unit circle. So we have that particular domain restriction. Keep in mind pi over 2 plus 1 pi gets us 3 pi over 2. Tangent of 3 pi over 2 is undefined. And if we were to subtract it, pi over 2 subtract pi again is negative pi over 2. So we'll take our tangent value. The tangent value is x, and we'll go ahead and set those so they do not equal pi over 2 and do not equal negative pi over 2. The reason I chose those values again is our intervals from negative pi to pi, and pi over 2 and negative pi over 2 fit within that interval. 3 pi over 2 does not. Negative 3 pi over 2 also does not. That would be an acceptable answer if we were to put it in interval notation. It would be a little nasty. Again, AP test, they'll leave our answer as x does not equal pi over 2 and x does not equal negative pi over 2.